projects. In this video, we are going to discuss about the project which is child kidnap detection using Yolo. So before getting into the execution, let me give you an overview of the project. So nowadays, more and more cases of child kidnappings are being happened, and this makes people worry about their children, how safe they are. It's a scary thought because when a child gets kidnapped, it not only hurts them but also their families. Even though we have things like cameras and security guards to help these children keeping safe, they can't always stop from things happening. So that's why we need to think of new and better ways to make sure that kids stay safe. So what are we going to do in this project? We address the urgent need for advanced technology to detect and prevent child kidnappings by introducing a novel approach called child kidnap detection using YOLO. YOLO, it stands for You Only Look Once. YOLO, it's a super fast and accurate at spotting things in videos or live streams. So we are using this in our project to detect child kidnappings. We are building an automated system by taking the surveillance footage for quickly recognizing if there is something fishy going on, like child kidnapping. So we use different versions of YOLO. So we use different versions of YOLO, that super fast and accurate techniques, and we train them on lots of pictures of kids and scenarios where kids might be in danger. Our goal is to make sure that these systems are really good at spotting when something serious might be happening. But we are not stopping there. Our system isn't just for looking kids, it also keeps an eye on how they are interacting with adults and the other people in the area and how these adults behave with those kids. So, moving on, how did we implement this project? So, first we have explored the data set, and then we have pre processed. That is, we converted images and defined bounding boxes, and pre-trained YOLO models are then loaded and enhanced with data augmentation. And then we trained all the models that are YOLO V6, YOLO V5, YOLO V7, and YOLO V8. After training, we evaluated all these models using metrics called mean, average, precision, recall, and precision. And then we select the best performing version. So among all the versions built, YOLO V5 excelled. So we have chosen for deploying it in the front end. And we use Flask with SQLite for developing a web application, and we have deployed our project there. So moving on, to implement this project, we need software and hardware requirements. So coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So coming to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So moving on to the algorithms used, these are various versions of the YOLO which are built in the project. So let's understand what is YOLO first. YOLO, it stands for You Only Look Once. It is a state-of-the-art object detection model that processes images in real time, which provides fast and efficient method for identifying objects within them. It operates by dividing the input image into a grid and predicts bounding boxes and class probabilities directly from this grid. Unlike traditional object detection methods that require multiple passes over an image, YOLO, it performs detection in just a single pass, which directly predicts bounding boxes and class probabilities for multiple objects simultaneously. This approach makes YOLO particularly well suited for applications requiring YOLO real-time processing. So among all the models built, that are all the versions built, YOLO V5 has performed well, so we chose it for deploying it in the front end. So what is this YOLO V5? It is a specific version or the iteration of the YOLO model. It represents an improvement over previous versions, which aims for better performance in terms of accuracy and speed. YOLO V5 has been optimized for various deployment scenarios in this project for detecting child kidnapping. So now let's execute the project. To execute it, first we have to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Let's understand each file and then we will execute the project. So here in the YOLO V5, YOLO V6 and YOLO V7 folders, we have the data set. So first let's see in YOLO V5 folder. Here there are three subfolders. One is train, valid, and the last one is images. So here in train, we have two subfolders. One is images and the other one is labels. In images, we have images related to child kidnapping. So we'll be using all of these images to train the Yolo V5 model. So here we can observe that there are 10,023 images. So now get back. Here in the labels file, we have annotations or the labels for objects in the corresponding images. So here each file it corresponds to an image file in the image folder. For example, this file it corresponds to this image and this file corresponds to this image, which provides details about objects locations and classes within the image. So similarly, we have for all these 10,023 images, all the 10,023 label files. So here we can observe there are 10,023 label files. And all these label files, they follow the YOLO format. I'll show you a sample. So I'm opening the first label file. Here, each line represents a detected object. So there are two detected objects in this file. Here, each line specifies one object class index followed by bounding box coordinates, which are normalized to image dimensions. So this is the X limit, this is the Y limit, and this is the width, and this is height. Similarly, we will have in other label files also. So now close this, get back. Similarly, we have in valid folder also. We can observe that there are images as well as labels. We use train folder to train the models and valid folder to valid all the models. That is validate the models. So by combining train and valid folder, here we got the images folder. So here we can observe that there are images along with their label files. So now get back. Similarly, in YOLO V6 and YOLO V7, each folder contains the same images, but they are annotated differently. Because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. Having separate folders, they helps keeping the dataset organized and ensure that each YOLO version receives the correct annotations it needs to function properly. So here in the sample file, we have all the images. So we will be using all these images as the test cases in the front end to detect child kidnapping. So now get back. So moving on to the static folder. In this folder, we have CSS, JavaScript, and Bootstrap files. So these files, they are important for project styling and interactivity. Moving on to the templates folder. In this folder, we have HTML pages utilized in the project. And they are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure and layout for displaying content to the users. Moving on to the app.py file, this Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And this is the model file, which contain the algorithm information, and this will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. And the last file we have is signup.db file. This file is a database file which is used to store the user information. Now we will execute it. To execute it, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. So now we have to compile app.py file. So give the command python space app.py and now click on enter. So this command, it will execute Python script and it will perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link and then click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we will sign up. So click on sign up link and enter all the registration details which we asked to be entered. I have already registered and have an account in it, so I will directly sign in. So click on sign in and give the username and the password. So I'm giving my username and the password. Now click on login. I have logged in successfully and I'm redirected to prediction page. Here we can see a choose file button. We need to click on that for uploading the images. So click on choose file. So these are the images which are taken from CCTV footage. So we have to use these images as a test cases to detect child kidnapping. I have told you this already. So I'm going to upload the first image. Click on open. Here we can observe that image is loaded. Now click on upload. So from the image, application has detected two things, that is one getting child kidnapped and the other one is non-kidnapped. So here we can observe that kidnap is detected and a red color bounding box is drawn around it with the label that kidnap and with 0.77 probability score. Probability score is nothing but it is the confidence level that how accurate the detection is. And here we can observe that there is non-kidnap. So let's upload some more images, get back. Click on choose file. So now we will be uploading this image. Click on open and now upload it. Here we can observe that there is kidnap detected and a red color bounding box is drawn around it with the 0.91 probability score. It is so accurate. Detection is very accurate. So now get back. Click on choose file. So now we will be uploading this image. Click on open and now upload it. So here we can observe that a child is being kidnapped and a red color bounding box is drawn around it and it has labeled it as kidnap. So let's upload some more images, get back. Click on choose file. So now we will be uploading this image. Click on open. Here we can see that image has been loaded, now upload it. So here we can observe that a person is being kidnapped and a red color bounding box is drawn around it and with the probability score of 0.89, which means detection is very accurate. So let's upload some more images, get back. Click on choose file. So now we will upload this image. Click on open and now upload it. So here we can observe that a kidnap is detected and a red color bounding box is drawn around it with the 0.85 probability score. So get back, click on choose file to upload some more images. Now we'll be uploading this image. Click on open and now upload it. So here we can observe that a kidnap is detected and a red color bounding box is drawn around it. So now get back. As of now, we did detection from the test cases folder. So now we will do detection from Google Images. So open the new tab. We will search for child kidnapping images. So we will save this image. I'm saving it here. Click on choose file to upload the image. We have saved it here. So I'm uploading this image. Click on open and now upload it. So here we can observe that kidnap is detected and a red color bounding box is drawn around it. We will try saving some more images. So this time we'll be saving we will save this image. So I'm saving it here. Click on choose file to upload the image. So this is the saved image. Click on open and now click on upload. So here we can observe that kidnap is detected. We'll try using some more images from the Google. So we will save We'll try to save this image. Get back, click on choose file. So we have saved this image, click on open and now click on upload. So here we can observe that a kidnap has been detected. So a child is getting kidnapped here. We will try using one more image, get back to Google. So we'll be saving. We will save this image. Get back to the application, click on choose file. We have saved this image, click on open and now upload it. So here we can observe that a person is kidnapping a child. A red color bounding box is drawn around him and labeled as kidnap with a 0.92 probability score, which means that it is highly accurate. That means detection is very accurate. So now get back. So in this way, we can observe that the application has worked with the folder which we have and also with the images which are in Google. So now we will see the graphs of the project. So click on about. So here we have F1 confidence curve graph of Yolo V5. So here on x-axis we have confidence score and on y-axis we have F1 score. Moving on, here we have precision and recall curve graph where on x-axis we have recall score and on y-axis we have precision score. And this is confusion matrix. And here we have precision score comparison graph where on x-axis we have precision score for each algorithm and on y-axis we have algorithm names. Here we can observe that YOLO V5 got the highest precision score. So we have deployed it. So this is the recall comparison graph. Similar to precision comparison graph, here also we have on x-axis recall score and on y-axis we have algorithm names. This is MAP score graph, that is comparison graph, where on x-axis we have MAP score and on y-axis we have algorithm names. So from all the three graphs, we can observe that YOLO V5 has performed well. So now click on sign out. In this way, just by uploading images to the system, it will detect whether a child is being kidnapped or not. So by using YOLO V5, we made things safer, showing how advanced technology can help solving big problems. By training it carefully and putting it into an ease to use the system, we have created a strong tool that can improve security and keep people safe, especially those who need it the most.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.